So far, we've learned about the basic relationship types and how to model relationships between tables. However, we've only looked at one use case. But in this movie, we're going to use a real-world example to apply what we've learned. In review, data modeling breaks into three phases. First, you develop a list of entities or tables that belong in your data model. Next, determine and diagram the relationships between those tables. And third, review the diagram for correctness and consistency, and possibly revisit steps 1 and 2 if necessary. Okay, here's a process description for this example. Take a minute to read this through, making special note where you think you'll see potential entities. And when you're looking for entities in your description, look for nouns. Go ahead and pause this video and finish reading. Using the nouns technique, we can identify our entities as events, members, and donations. Each of these entities are in fact different and discrete types of data, and each can be described differently from the others. Let's also make note of the phrase donations that are made by more than one member at a time for later reference. Identifying these entities tells us what tables we'll need to define in our database. These will then become our entity list. Identifying the tables is only half the task. We must then determine how they are related to each other. And this is where you want to create an entity relationship diagram, otherwise known as an ERD. In ERDs, it's common to represent your entities as a box with an entity name inside of it. Next, we'll move on to exploring relationships between the entities, starting first with members and donations. We will use questions formatted within the one-to-many logic that we've been using throughout this title. In this example, here are the questions we should ask. Can each member potentially have many donations? Yes, we actually see this in the description where there's a reference to donations made by their members. Now, can donations be made from one and only one member? No. In our process description, it also states donations that are made by more than one member at a time. So what we have here is what we call a many-to-many relationship. And if you recall from previous movies, the way we resolve a many-to-many relationship is by adding a third join table to our diagram. We'll add a new join table to this diagram, and we'll call this one members donations. When naming a join table, I like to combine the names of the two parents so that we know what type of table it is when we see it in our diagram. So we'll visually represent the relationship between each parent and child table with a line connecting the two boxes. These lines will have a double hash on the members donation side because that serves as the child in both of these relationships. Now let's look at the rest of the entities, and let's evaluate whether there's a relationship between donations and events. Now here, the question we'll ask will be, is each donation associated with one and only one event? In this example, yes, donations can only be associated with a single event. Now, can each event potentially have many donations in the system? Again, our description mentions a record of all donations generated by each event, so yes. This tells us that there's a one-to-many relationship between the two entities, with donations as the many. We'll want to represent that on our diagram as well. Now let's take a look at the entire diagram with all the relationships in place. The one thing to note here is that although the relationships are not drawn between members and events directly, these tables are still related through a chain of relationships. For example, a member could submit a donation when they're attending an event, and therefore that member is indirectly related to the event through this chain of relationships. Once our relationships are in place, we can now determine which tables need primary keys and which need foreign keys. We'll begin first with the primary keys. In review, we see the following tables acting as a one or a parent in their relationships. Members are a parent to members and donations and will require their own primary key. And donations are also a parent to members and donations and therefore need their primary key. And events are a parent to donations and thus will require a primary key as well. Now finally, the foreign keys. In review, we see that the following tables will be acting as a child or many in their relationship. Donations are a child to events, so they'll need an events foreign key. And member donations are a child to both members and donations. So we actually need two foreign keys in this table, one foreign key from donations and one from members. Going through all these steps in your planning stage will help you make sure that all of your relationships are one-to-many relationships. and it'll also help you determine which keys you're going to need inside of each table. So that's a quick rundown of applying relationship design to a nonprofit donations example. Feel free to use this structure if it maps to your situation.